Hello everyone, I'm Sam Devlin, a senior researcher in game AI, and it is my great pleasure to welcome you all on behalf of Microsoft Research to our AI and Gaming Research Summit. We have an amazing audience of researchers, creators, and innovators from across academia, the gaming industry, and Microsoft in attendance today. We're delighted to bring you all together to share ideas and discuss how AI and machine learning is transforming the landscape of gaming. I'll hand you over now to Hyan, who will introduce our program, but I'd like to take this opportunity to encourage you all to engage actively in the Q&A sessions so that we can learn from the experience of everyone in attendance today.
Hi, I'm Hyan Jung, Chief of Staff for the Xbox organization. Thank you to Microsoft Research for hosting this event. In the past 20 years, Microsoft Research has been a strong innovation engine for Xbox, as well as making valuable contributions to games and AI research. And it's great to see that conversation continue with this event. On behalf of gaming at Microsoft, welcome to our MSR colleagues and academic and games industry guests. We have a great agenda for you over the next 2 days. This summit event is focused around 4 themes, which are very pertinent for the industry right now. AI agents for gameplay and game testing, responsible gaming, including ethics, safety, and inclusivity, computational creativity and content generation, understanding players, player engagement, and analytics. There are parallel sessions, and you will have a separate Teams link for each one. Finally, let me introduce Peter Lee, Corporate Vice President of Research and Incubations at Microsoft, to tell us more about Microsoft Research.
Thank you, Hyan. It's really my great pleasure to welcome you all to Microsoft's AI and Gaming Research Summit. All of us here at Microsoft Research are delighted to bring together this community, which spans fundamental researchers to advanced product developers, social scientists, and game players. I have the great privilege to work every day with the amazing people here at Microsoft Research. We do fundamental research to advance human knowledge, particularly in the computing and related fields, but we also work in close collaboration with teams across the company, solving hard problems, inventing new technologies, and maybe most importantly, doing what we can to peer into the future. Almost everything we do here at Microsoft Research is published openly, typically in the form of research papers in open archives and at top academic conferences and journals, and our source code published openly in GitHub. All of it really represents the work that is done in collaboration with great people across the company and at hundreds of universities, nonprofit organizations, and companies around the world. Now, the way I like to think about Microsoft Research is that we try to think hard about a point in the future, let's say 10 years from now in the year 2031, and ask, what will be inevitably true about people and the world in that future date, in the year 2031, that is different than today? And in what ways will a path from today to that changed future world create opportunities or disruptive challenges? By thinking in such terms, we can work backwards from there to understand what we should be working on today. And almost always, that work will involve tight integration and collaboration with teams around the world. Now, the agenda for this AI and Gaming Summit is, in a way, a product of this type of thinking. So we're incredibly excited for all of you to be here with us today to facilitate open discussion spanning academic and industrial work, to better understand perspectives at the intersections of AI and gaming research. I hope you're looking forward to it as much as I am. Now, I'm incredibly honored and pleased to introduce the head of Xbox, our executive vice president for gaming, gamer and all-around great human being, Phil Spencer, also known as P3. Phil?
Thanks, Peter. I'm honored to be speaking here today. For those of you I don't know, I'm Phil Spencer. I'm head of gaming at Microsoft. I started at Microsoft in 1988 as an intern. That's about the same time that MSR was created inside of Microsoft. And it's great to see the breadth of technology, research, and the contributions to Microsoft and to the industry that MSR has made over those times. The game industry is powered by innovation. At Xbox, our challenge is to innovate in ways that create lasting forms of differentiation and delight for our customers. And we're continually trying to innovate, pushing the boundaries of what we think is possible and challenging the assumptions that we make inside of our own industry and our own teams. Xbox is working with Microsoft Research in areas like machine learning to assess player skills ranking, matchmaking, community moderation to make sure our platform is safe and inclusive for as many players as possible, and tools to make the creation of games easier and more efficient for the amazing creators in our industry. At Xbox, we're committed to great innovations that empower players to play the games they want with the people they want anywhere they choose to play. We believe these sit at the center of the new thinking around technology, business model, and player experience. We see this cross-disciplinary thinking throughout the history of video games. Toru Iwatani saw a gap in the market for a game that could appeal to everyone, to create a new pastime. Through user insight, great game design, new technology, Pac-Man was created, the highest grossing arcade game of all time. The first console was created in 1967. Brown Box by Ralph Baer and his colleagues at Sanders Associates. The first cartridge was created in 1977. It took almost 10 years. This opened a new channel for game development and launched an industry that is thriving today. The ultimate goal at Xbox is to bring down the barriers to play and bring gaming to everybody on the planet. In order to do that, we need to unlock the technology that creators will use to create amazing experiences for the 3 billion gamers and growing around the planet. We've invested with our partners at AMD around RDNA, Zen 2, to allow our creators to create more realistic and immersive experiences. We've invested in hardware-accelerated DirectX ray tracing that simulates light and sound in real time more accurately. And ultimately, this technology gives power to game creators to realize their vision. And technological innovation is not the only area that we as an industry need to innovate. Business model innovation can also unlock new opportunity. Xbox Game Pass is our game subscription service that has over 18 million subscribers and hundreds of games for gamers to try. And what we find is when gamers have more seamless opportunity to try new games, games they might never have tried through a retail-only model, they're doing exactly that. They're trying genres, they're trying games from new creators, they're more adventurous, and they're spending more time playing great games from creators around the world. Games like Microsoft Flight Simulator or Tell Me Why are strong members of our Game Pass portfolio and just show what happens when you unlock the potential for more players to find more games. As we were designing our new generation of consoles, Xbox Series S and Series X, we were simultaneously designing the infrastructure for Project X Cloud, which is our game streaming technology that we're going to use to unlock the capability to play these games to millions and millions and potentially billions of customers. The platform is actually one and the same. Our developers who are building games for Xbox Series S and Series X today are building Project X Cloud games at the same time by building exactly the same game that we will run through our data centers. Our collaboration with our partners in Azure has uniquely positioned us to be able to put Project X Cloud racks in Azure data centers around the world, unlocking the capability for us to find new players in new markets and on new devices with the power of gaming content. Now today, it's really about a shift of how games are distributed. I build an Xbox game, and now through the power of the cloud, somebody can experience that game on a number of different screens. When we look in the future, we see a world where game creators will natively be building cloud-based games first, They will think first about their game running in the cloud with almost unlimited access to the hardware capability that's available in a data center. They'll be able to scale the capabilities of their games up and down, potentially hosting hundreds of thousands of players in a game or making use of multiple CPUs and GPUs in the cloud to deliver experiences that no local hardware could unlock. But all of that is really how we do things. More important to us at Team Xbox is why we do what we do. And ultimately, we believe in the connected power of video games. Gaming is community. Players come together to play, to view other people playing video games, to talk about their love of games or studios, and just share the joy that they've had in playing. And that community creates a real opportunity, and we see it. People meet new friends playing video games together. They meet new friends watching other people play video games. And gaming has a unique power to bring people together across geographies, socioeconomic backgrounds, religion, gender. It can really help us unify through these shared experiences. And we believe with that connection comes more empathy and understanding and communication between groups. And we think that's an incredibly important thing on the planet right now. I'm looking forward to great conversations between Xbox, Microsoft Research, academia, the games industry, and partners. I'm really excited about the potential for machine learning and AI to revolutionize our industry, allowing creators to bring more immersion to the games that they're creating, to allow us to create more realistic storytelling through smarter AI agents and more believable worlds that players find themselves in. Through addressing accessibility, allowing more people to play in safe and inclusive ways so that players everywhere can experience the power of gaming. So let's embrace learning together. Let's be unafraid to disrupt ourselves and be open to ideas and new discussions. Innovation is the only true form of lasting differentiation. And innovation can help us address challenges and opportunities in new ways. So I encourage everyone to innovate and bring gaming to everyone on the planet. Thank you.
Thank you so much for that, Phil. Thank you so much for that, Phil. It was a great introduction. I'm Katja Hofmann. I'm in the outreach team at Microsoft Research. It's my great pleasure to introduce our next speaker. Katja Hofmann leads the game intelligence effort at Microsoft Research Cambridge here in the UK. She obtained her PhD at the University of Amsterdam, is really one of the world's leaders in reinforcement learning. What I love about Katja is just the fact that she's such a great collaborator, both across Microsoft Research, across teams within Microsoft, but also with many of you in academia. So I can think of no better person to give us some deep insights around the intersection of AI and gaming research to kick off the summit. And I'm really delighted that she'll be taking live questions at the end of the session after her talk. So do pop questions into the chat box on Teams Live, and we will get to as many of those as we can at the end of the session. So with that, I'd like to hand over to Katja. Take it away.
Welcome to my talk on gaming as vanguard of AI innovation. My name is Katja Hofmann, and today I want to talk about why the intersection of AI research and gaming is such an incredibly exciting area. To me, there are really three main reasons. First, and very importantly, gaming is huge. On a personal level, gaming is of course a way for us to relax, to connect with loved ones, to socialize and meet new people. And if anything, this is a trend that has only been accelerated during the COVID pandemic. On a global scale, this means that gaming is by far the largest entertainment sector. And on top of that, it is one that is growing very rapidly. Currently, game studios and big players in the industry are looking to understand how they can reach the next billion players. And this means that for people who are innovating in the space of AI and gaming, there is the potential to create entirely new gaming experiences, new ways to engage for the estimated 2.7 billion players that are already playing games regularly. This means there's the potential for this innovation to reach about 1/3 of the world's population, and that proportion is even growing rapidly. Secondly, games in themselves are a really fruitful testing ground for new AI technologies. For example, in our work on Project Malmo, my team and I built an AI experimentation platform on top of the game Minecraft. And this allows researchers around the world to answer fundamental research questions. For example, how to create agents that can learn to generalize beyond the specific experiences that they have seen during training. So, for example, how AI agents could generalize to new maps within a game or new levels that they haven't seen before. Similarly, this allows researchers to tackle questions around multi-agent learning. So, for example, how agents can learn to effectively coordinate with each other. These fundamental insights are not only interesting from a research perspective, but beyond their immediate interest and curiosity, they could lead to many new applications, both within games and beyond. This brings us to the third reason why the intersection of gaming and AI is such a fruitful space. There is huge potential for impact to go beyond games. So, for example, the team in the Autonomous Systems group focusing on Project Bonsai is already using reinforcement learning algorithms, many of which have been developed in gaming scenarios originally, to work with industrial partners on many applications for industrial control. To me, that's a hugely inspiring type of project because it shows that the fundamental insights that we gain can be applied both in exciting gaming applications and in other real-world applications. And I expect to see a lot more examples in the years to come. Within my team at Microsoft Research in Cambridge, all three of the motivations I just mentioned guide and inspire our work. You can see that usually we are based in the beautiful Cambridge lab here. Usually we now collaborate within teams. And jointly we pursue fundamental insights in artificial intelligence, especially a type of technique called reinforcement learning, motivated by real-world applications in gaming and beyond. In a nutshell, our vision for long-term research, if you will, our long-term research agenda, is to create agents that learn complex behaviors and that learn to genuinely collaborate with human players. For example, I already mentioned Project Malmo, which is a fantastic testing ground for understanding how agents can learn complex behavior, generalization, and coordination. I won't be able to go into much detail here, but if you want to learn more about some of the latest research that is happening over in Project Malmo, I recommend a webinar that was recently broadcast and that is now available on demand. This was presented by our colleagues at Queen Mary University, Renuka Gena and Diego Perez-Libana, their PhD student Martin Balla, as well as my colleague Sam Devlin. This webinar focuses on recent advances and challenges in multi-agent learning, and it uses Project Malmo and Minecraft as a testing ground for showcasing some of those insights. And if you want to see a latest update on some of the work that's happened in connection to competitions run on Project Malmo, Will Goose will be able to give an update here at the Game and AI Summit. Will is the lead organizer of a series of competitions that have been built on top of Project Malmo. The most recent one was at NERS 2020, and it was the second instance of the mineral competition, which focuses on understanding how AI or reinforcement learning agents can effectively use human demonstration to learn complex behaviors. For example, understanding how to search for a diamond in Minecraft. Here at the event, Will Goose will be giving an update on the competition as well as announce the winners of the competition, and I am personally hugely excited to hear about the latest insights and results. moving to the screenshot on the right, here you see another game that we used for our research. It's called Bleeding Edge, and it's a team-based game, 4 versus 4, that requires tight coordination between team members in order to control points within the map and compete effectively against an opposing team. This is a fantastic game for us to test out more closely how AI agents could learn such coordination, first among each other and eventually with human players. You will be able to hear much more about our work using Bleeding Edge together with our colleagues at the Ninja Theory Game Studio, as well as the open challenges around achieving genuine collaboration with human players in the talk that will be given by my colleagues Sam and Raluca, again here at the AI and Game Summit. The work in my team is usually on the basis of reinforcement learning, and so I want to just give a few-minute overview for those who are not yet familiar with this type of technique about the basis of reinforcement learning and why we think that is such a potentially useful technique. In reinforcement learning, an agent, for example, a non-player character or a bot within a game, can be modeled as being placed, embedded directly in their environment, which they perceive through a series of state observations, so essentially the current game of the current game state. They interact with the game through taking actions, and they also observe a reward signal. The reward signal is crucial because this is how the game developer or experimenter would express the goal of the agent. For example, it might get a positive reward for reaching a goal, a negative reward for being defeated in a one-on-one match. And so this could potentially allow game developers to create behaviors that aren't so much scripted in all their nuances, but instead it would allow a developer to just specify the high-level goals of the behavior, whereas then the agent, through interaction with the environment, discovers the kinds of strategies that can be effective for achieving this goal. And this can make reinforcement learning agents, a very effective tool for developing games, ideation, and other creative processes. Just to give you an example of what is already possible today, I'm using a demo that we have published under the name Project Pedia, in which we discuss the challenges of collaboration, both in the simplified game environment, as well as in the game Bleeding Edge that I already mentioned. Just to give you an example of what coordination in a simple game could look like, here I have recorded a video of myself, shown in the image as the white robot at the top of the screen, playing together with an agent that has been trained using reinforcement learning. Now, in this environment, my goal is to escape from this room, and in order to do that, I need to open the door. It is set up as a coordination task, so one of the two agents here has to visit the two buttons that you see in yellow and blue. One has to then activate the red button so that the doors open. And you can see as I play this video over here that my cooperating agent, shown in blue, is actually trying to understand what I will do before it then complements my action, activating the control points in blue and yellow so that the doors open, allowing me to successfully escape. This kind of behavior emerges purely from exposing the reinforcement learning agent to a wide range of settings in the game that could possibly occur. So all we have done is specify the goal of helping the other agent, in this case the human player, escape, and a wide range of nuanced behaviors emerge during training. You can already see some of these kinds of techniques used in practice, and in fact we have collaborated with a team in Azure to bring a reinforcement learning on Azure to customers. This is now available in early preview, and if you would like to explore reinforcement learning, you could try this out. The link is shown here on the slide. So after giving you an overview of why games are such an exciting ground for innovation in the AI space, as well as some of the work that my team is doing in this space, I want to use the remainder of this talk to give you some examples of how the work of our colleagues at Microsoft Research is combining these different aspects of fundamental new insights as well as real-world impact, both in the gaming space and beyond. First, I will show you 3 examples of projects that have already achieved such type of impact and that are already affecting the way people play games today. Starting with the first example, this is an example that uses personalizer for the game store. The game store is really important for players because this is, of course, how they discover new engaging content. And the personalizer is a project that is particularly close to my heart because, as far as I know, this is the first application of reinforcement learning for these types of customer settings. In this example, the personalizer is used to personalize the spotlight that you see shown in big yellow advertising the game Cyberpunk in this instance. This spotlight is one of the most prominent slots on the game store. In this case here, personalizer is used to decide what game to highlight and given the player's profile, given the types of games that they have already played. So just a brief look under the hood here. Briefly, personalizer uses reinforcement learning in order to learn what content is the most relevant to a given player as they enter the site, given a reward signal. And in the case here, the reward signal is a type of measuring engagement which is carefully decided by the creators of that particular personalizer application. In this example, the personalized experience created using personalizer has been compared to their previous heuristic approach, and it is actually leading to a measurable increase in uptake of the games that are presented to users. So we know from those results that players find the content that is provided to them more engaging, leading overall to a better player experience. In order to learn more about the theme of understanding players, I highly recommend that you take a look at the track on understanding players, player engagement, and analytics here at the Game and AI Summit. One talk in particular that I would like to highlight is that by Abby and Francisco, who will be continuing on the topic of personalization and talking about how their journey is currently shaping up within the game of Minecraft. So, hugely exciting topic. The next project I want to highlight is one that uses machine learning for optimal matchmaking. And this is an experience that is already deployed in Halo 5 and is used by hundreds of thousands of players that play Halo every single month. In an online multiplayer game, a good match is crucial for a good player experience. Ideally, you want those matches to be as evenly matched as possible. So if you play against another player with almost exactly the same skill level, then the match is very unpredictable. The chance of winning for you is essentially 50-50. And the team knows from their previous research that that is the most engaging and most exciting kind of match. Previously, so before introducing this technique using machine learning, the team had to essentially hand-tune a complex formula on how to create those matches, essentially on an hourly basis. And even with this hand-tuning, the matching wasn't very good, for example, looking at different distributions of players across geographies. Now they are using a machine-learned model both to predict traffic and a reinforcement learning solution to automatically tune the matchmaking equation on a very regular basis so that it can automatically adapt on a continuous basis to the traffic that is actually experienced. This leads to a much better matchmaking overall, and is also able to capture those geographic nuances that were previously impossible to capture. So again, this is a fantastic example of how research done initially at Microsoft Research or in collaboration with Microsoft Research is already impacting players today. The third project in this category that I want to highlight is Suffix, and this is a project led by Junjie Lee at Microsoft Research in Asia, and he and his team were able to train the world's best mahjong player. So briefly, just in case you're not familiar with Mahjong, it is one of the oldest and most popular board games. And according to Wikipedia, it's a game that requires tactics, observation, memory, and adaptive strategies. It is very challenging because it has a huge amount of hidden information. So if you would take a look at the game board here, there are 144 tiles in total, and many of those are in play but still hidden. So a player has to reason about the kinds of tiles that might still come up later on in the game, and they have to adapt their strategy accordingly. The achievement here by the team was that they found a way to deal with this huge amount of hidden information and actually train an agent that is now outperforming the best human players. This is, of course, a really exciting demonstration of the types of performance that can be achieved by this type of machine learning. But as important, it has already impacted real human players. And in fact, some of the top human experts are now training with Suffix using its strategies in order to improve their own play. If you would like to learn more about exciting advances in AI agents, then definitely take a look at the AI Agents for Gameplay and Game Testing track, again here at the Game and AI Summit. The final 3 projects that I would like to discuss with you are 3 research projects that have high potential for future impact. So these are a little bit further out, still a little bit more on the fundamental research questions side, at the same time very high in ambition, and I see a lot of potential for them to impact how games are developed and played, as well as applications beyond gaming. I want to start by highlighting a project that will be presented by Alexandra and Maria at the conference this week, which focuses on understanding how people form social bonds online, and especially how they do so in online gaming communities. So the key challenge they tackled was to understand how self-disclosure and trust interact as a basis for understanding how to create more healthy online communities. In their approach, they first of all conducted a large-scale study on self-disclosure and trust, and I believe they had almost 47,000 respondents to this survey. So the scale of this is just incredible. They analyzed and also contrasted the responses they received to an automatic analysis of gamer forums, which used techniques from natural language processing. To learn more about the findings, of course, you should definitely go and watch their talk. But I personally thought it was really interesting that they found key differences between different types of communities, for example, based on the games that people prefer, and of course, their implications for creating tools that could result in more and safer and healthier online forums. So of course, here the implications are really important for creating safer gaming spaces. And even going beyond gaming, there are big questions around how to create trusted environments in online settings. So the implications, again, here go far beyond gaming. To learn more about this and related topics, do take a look at the related track on responsible gaming, including ethics, safety, and inclusivity. And 2 talks in particular that I want to highlight here are by Microsoft Research colleagues. So do check those out. The second project in the space is a project on human AI co-creation for games and games creators. And this is research led by one of my team members, Mikhail Jacob. Mikhail is really interested in the space of how game creators could eventually use techniques like reinforcement learning agents that we have already discussed in order to express themselves creatively and create new and engaging content. However, there is a key challenge, and Mikhail observed that there is a disconnect between the potential that some of those technologies create and the types of workflows and tools that are actually available to game creators in practice. He started to tackle getting a better understanding of the space by conducting a survey of game industry professionals. And this survey surfaced really interesting sets of challenges and opportunities in adopting recent AI technologies in game development. You can see a brief overview of the kinds of themes that were discovered in his work here in the figure on the right. But of course, there's a lot more detail to this, and you should definitely see Mikhail's talk to learn about the study in more detail. Mikhail is already taking on board some of the implications of the study and is actually exploring how to create new tools and new workflows for game creators to effectively leverage the power of AI techniques such as reinforcement learning in their everyday work. And finally, if you would like to learn more about computational creativity in a project that is already used in current game environments, then you should check out Jörg Neumann's talk in the computational creativity track. And more broadly, of course, this track is highly recommended for anyone wanting to learn more about computational creativity and content generation. Finally, in the context of projects that are a little bit further out and focusing on fundamental new insights that can eventually lead to high impact in gaming and other real-world applications, I want to highlight the work of Adith and Brian that will be presented at the AI Agents track here at the summit. Adith and Brian started from a similar observation to the one that Mikhail is also exploring. Understanding how AI agents could be, or AI agent technology could be used more effectively by game creators who don't necessarily want to learn all the details of latest algorithmic advances in reinforcement learning. Their key focus should really be on how to create that engaging new game experience. They're exploring a range of techniques that they will be discussing. So for example, they are looking at how to visualize learned agent behaviors in order to allow game creators to gain insights into the kinds of behaviors that have been learned. They are looking at providing more control over those behaviors using calibratable AI. So again, as you can imagine, the potential for this type of technique is very large, not only in terms of understanding how game creators can leverage these types of technologies for creating new and engaging game content, but at the same time, eventually for enabling a wide range of application developers to use these kinds of techniques effectively in their real-world applications. So again, if you want to learn more, do check out the talk of Adith and Brian. Before I close, I want to do two things. First, I want to say a big thank you to the organizers. It's such an honor to be invited to give the Microsoft Research keynote at such an exciting event, and especially among such amazing speakers. Second, I would like to invite you to make use of the unique opportunities for engagement and connection that are provided by this event. Both in our group of presenters and in our audience, we have experts that have gained experience in the game industry for decades. There are others who have recently joined and provide fresh new perspectives. There are academics who have done research on a wide range of AI techniques and who are the world experts on the latest state of the art on a wide range of these techniques. So I invite you to try and understand how you can engage and make use of this event in order to discover new opportunities for gaining fundamental insights and for connecting those insights to applications in gaming and other real-world applications. For example, there will be live Q&As after the talk sessions, so your questions and thoughts are highly appreciated there, and you could take the engagement to social media as well. Whichever form of engagement you choose, I really look forward to your questions in the Q&A here and additional discussions at the conference. Thank you so much for your attention.
Thank you so much for that great talk, Katja. We've had a bunch of questions come in over the chat, so thank you to all of you tuning in for those. So we're going to go through those. A lot of you upvoted those, so yeah, there's some tough to choose from, really. So there's a really interesting one. Reinforcement learning looks really promising for in-game experiences, but maybe you can talk a little bit more about the opportunities for RL for testing and development and what Microsoft's doing around that.
Mm-hmm. That's a fantastic question, and thank you so much for everyone for listening and for sending your questions, and of course Kenji for inviting me and hosting the Q&A. As you noted, or as the questioner noted there are a lot of hugely exciting opportunities for reinforcement learning in the gaming space. On the one hand, that is for game experiences. On the other hand, that is for tooling. So how do we empower game developers to use reinforcement learning as part of the game development process? Both of those are topics that my team is very excited about and that drive the research directions that we pursue. So for example, in order to allow game developers to use reinforcement learning effectively for game testing, we need to push on the sample efficiency and robustness of reinforcement learning. And there are also key challenges in generalization. So for example, understanding how we could train game testing agents that don't break every time there's a small modification to the map. Those are just some of the challenges that we have a good understanding on and that we work on solving. As we progress in reinforcement learning and related areas, I'm certain that there will be a lot of opportunity for impact, both in terms of creating new game experiences and in terms of creating those tools for game creators.
That's great. I think ultimately it benefits the players, right? So
Absolutely.
That's fantastic. Yeah, just want to follow up on that theme on just the training, really. Got a question around how long it takes to train, right? So it takes a long time to train these on games. So are there any sort of techniques that can be used to speed up that training process?
Mm-hmm. Absolutely. And again, that's a fantastic example of how the understanding of how ultimately we want to impact gaming can inform and really drive our research agenda. So sample efficient learning is top of the list for my team. And so there we are exploring techniques that range from imitation learning, where we start from, for example, demonstrated player behavior to allow reinforcement learning agents to bootstrap from that initial behavior, to effective uses of uncertainty estimation, for example, to allow agents to more effectively explore an environment so they can get away with much smaller amount of data rather than with maybe vanilla reinforcement learning approaches. Again, as you mentioned, those are really key to making sure that these tools eventually reach game developers and by extension, the gamers themselves. I also wanted to point that this is one question that is picked up by my colleagues Raluca and Sam in their talk in the AI agents track. Especially Raluca has worked with the Bleeding Edge team to understand how we can train effectively in that game. So if you're interested in the kinds of tricks that we're already using in order to make training in games more sample efficient, then do check out that talk.
Oh, great. Thank you, Katja. Thank you, Katja. And then again, just kind of on those lines as well, a little bit is, you know, are there ways or tips or ideas where we can make learned RL policies appear a bit more natural for non-player characters? Right now, the players can act in a kind of particular way, maybe a bit wooden or a bit strange, and they can appear quite jittery or unnatural. So yeah, have you got any sort of comments on that type of work?
Mm-hmm. Fantastic thought. And in fact, I strongly believe that one of the key opportunities for reinforcement learning agents in games is to exactly enable this type of more natural behavior that you couldn't achieve using traditional AI techniques, for example, scripted behaviors. We've already seen that with reinforcement learning, we can get much more nuanced behavior. So for example, in our Project PDA demo on the AI innovation website, we can see that agents can be trained to quite naturally respond to human interactions within a game. At the same time, what what it means to kind of have natural behavior can very much depend on the particular style of game that a creator is aiming at. So the kind of core of this question really to me is how we create tools that give the game creator control over the kind of behavior they think is natural for their particular game, for their particular title. And in this context, I'm thinking of work that my colleague Mikhail Jacob is doing in his work on designer-centered reinforcement learning. We just put out a blog post where he and our former intern Batu are discussing the fantastic work in this space that they've been exploring, really trying to understand how to give game developers this control over the experience that they can create. And in addition to that blog post, I also encourage you to check out Mikhail's talk here at the event, where he will be talking more about opportunities in the kind of the creative space of co-creating between game developers and the tools that we develop.
That's really great. That's really great. We talked a lot about the great things about RL. I had an interesting question come in around, are there sort of common pitfalls? What are the types of things that ML is good for? Maybe areas where it's not so good for, and maybe people shouldn't focus on so much.
That is a really interesting question. In general, if you think about reinforcement learning, it's only as good as the reward function that the game developer provides to the agent. So as I discussed in my talk, reinforcement learning kind of creates this shift where instead of really specifying in detail what kind of behavior you want to see at each point in the game, instead now the creator specifies the goals in the form of a reward function or a similar structure, and that really expresses the goal for the agent, and then the agent will, through kind of having enough access to data, figure out what optimal behavior looks like given that particular reward structure. So one caveat that comes to mind immediately is that in a space where we are not able to very easily specify that reward structure, those might be very hard to create agents for. So those are definitely areas where future research is needed to understand how goals or rewards could be specified in a different way in order to make those areas more accessible.
Thank you. Actually, there's a question on that theme, which is, are there any particular areas or combinations of different methods in this sort of space, imitation learning, novel architectures, less handcrafted rewards, which are kind of helping push these techniques forward the most right now, or maybe in the future?
Absolutely, that is a fantastic question. In a lot of the kind of academic work, we see that people are exploring very excited directions. So, for example, people might be focusing on imitation learning. They might be focusing on curiosity or notions of intrinsic motivation that allow an agent to more effectively explore a world or discover what's possible within it. In practice, what we're seeing in terms of trying to get things to actually work in a game like Bleeding Edge is that usually we need a combination of those different techniques. So, for example, we are seeing very strong results when we initialize a policy using imitation learning and then use a combination of imitation and reinforcement learning in order to get to that very sample efficient learning that is still able to improve over a potentially suboptimal demonstrated behavior, or in order to generalize that demonstrated behavior to a wider range of settings. So understanding how to combine reinforcement learning with other types of approaches in principled ways are really a really exciting research direction that we work on in my team, and that I also look to the academic world to solve additional challenges there.
That's great. I think we've just got time for one more question, really. There's one that's come in less on the technology, but more around pretty simple question. How can people get to work at Microsoft Research, students, researchers? Maybe you got some advice for that on that.
That is a fantastic question. I already mentioned the work of our former intern Batu and the blog post that has just resulted from that work as one example of how amazingly excited I am about the creative ideas, the expertise that our interns regularly bring to our team. There are other forms of collaboration. For example, we have a very successful AI residency program where we get to collaborate with teams of brilliant young minds, often in collaboration with product groups. And most recently, the outreach team announced the Reinforcement Learning Fest. I think it's called, Reinforcement Learning Open Source Fest. And that's another really exciting opportunity for students to contribute their ideas and actually get something to work in the reinforcement learning space. And I know, Kenji, as part of Outreach, you are leading or collaborating on creating many of those opportunities. So maybe you have additional thoughts or advice on what resources students in the audience should check out to see what opportunities there are.
Absolutely, yeah. We run lots and lots of different programs, too many to go through right here, for all sorts of students and researchers and postdocs and faculty members. So we've actually set up a tab on the event website. So if you go to the event website, just search for AI Gaming Research Summit, and there's a research opportunities tab that has links to all of those places for those different opportunities, like the RL Fest, and also internships and career opportunities as well. So just jump on the event website, click on research opportunities, and you can see what's there. So unfortunately, we've run out of time. I think we could talk for a lot more, but actually, we do have many sessions coming up. So lots more opportunities to dive into more Q&A with other speakers around a lot of these topics. So look forward to that. So what we have coming up is 2 parallel sessions. There's an AI agents session and a computational creativity session coming up at 25 minutes past the hour. So there are separate Teams Live links for each of those, which all attendees should have, and you got an email this morning with those to jump into. So please just go there. I think our slide coming up with has those links. So with that, I just want to say thank you to everybody. To Katja, to Phil Spencer, to Peter Lee, Hyan, Sam, for really kind of setting the scene for the summit for the next few days. And we really do hope that you find the event valuable and you get a lot out of it. And so, yeah, please do choose whether you want to go to AI agents or computational creativity. Don't worry, though, the sessions will be made available online as videos on the event website in the next week or 2. So you won't miss anything, but do jump to whichever your preferred session is right now. So with that, thank you very much, everybody, for participating in this opening plenary. Thank you.